Hello everyone. So in this video we will discuss that how we can insert a node in a singly linked list at a given position. So here you can see that in this problem we want to implement a method which will insert a node in a singly linked list at a given position. And this position we are assuming to be valid and it will start from 1. So for example, here you can see that we are given, let's say, with the singly linked list. And now let's say if you want to insert any node at a given position. So here we are assuming that position to be valid. It means that position should lie from 1 to whatever is the length of the singly linked list. And here we are starting it from 1, which means if you want to insert a node at position 1, it would be the first node. And if you want to insert at position 5, then this would be the last node. And in case if you want to insert in between of these nodes, the position would be the number where we want to insert. So let's say if you want to insert at position 3 and we are given with this singly linked list. So here you can see this is position 1, 2 and 3. So what we are trying to do here is we will insert node here and this node will get shifted ahead of the node which we want to insert here. So let's go ahead and see the demonstration of this algorithm step by step. So before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So now here you can see this is the algorithm to insert a node at a particular position. Now let's suppose if we are given with this singly linked list having only 2 nodes. So we'll apply this algorithm on this singly linked list. And let's say if you want to insert a value 8 at position 1. So the second parameter is position and this is the value which you want to insert. So here you can see that whatever the value we have passed, which is 8 here, it's nothing but our data. So in the first step what we are doing is we are creating a list node having data as 8 because we want to insert this node at position 1. So it would look something like this, that node is pointing to a list node having value as 8 and its next is pointing to null. Now here you can see that there are 2 cases in if and else. So if position is 1, it means we want to insert this node at the beginning of singly linked list, which is just before our head. So currently this if block condition comes out to be true. Now as we want to insert this node before head, what we have to do is, as node is pointing to this list node, its next should point to head because we want to insert this node before head. So this node's next should point to head. So in the first step we are doing that, we are assigning the value of head, which is this node, to node's next. So currently node next is pointing to null. So after this assignment, node's next will point to head. So it would look something like this, that now node next is pointing to head. Moving ahead. So here you can see that node next is pointing to head, but as head is pointing to the node having value as 10, which is our second node, we need to reassign this head to this node because in order to insert a node before head, which is the position 1, after insertion head should point to that node, or else when this method will get exit, this node won't be part of our singly linked list. So we need to assign head to this node so that this node comes into the singly linked list. So we are simply assigning the value of node to head. So head is pointing to the second node. Now it will point to the node which we want to insert. And here you saw that after inserting the node at the beginning, this was our position 1. Initially at position 1 was this node which shifted towards right and this node came into position 1. Moving ahead. Now let's suppose if we are given with this 3 nodes and we want to insert a value 7 at position 3. So here you can see this is position 1, this is position 2, and this is position 3. So we want to insert node here, and once we insert node here, this one will be shifted a node ahead because we want to accommodate 7 between 10 and 1 because this is the third position. So let's see how we can do that. At the first step, we'll create the node with the data as 7. We check whether position is equal to 1 or not. So position is not equal to 1. So the else part will be executed. So friends, now idea behind this algorithm is we want to insert a node at position 3. So this is the position 3, which means we want to insert this node between this node and this node, so that once this node is inserted, our new node is at position 3. So in order to insert this node at position 3, what we have to do is we need to traverse somehow to position 2, and then we can break this link, and instead of pointing to node 1, we can point to our node 7, and node 7 will point to 1, and by this way our node will be inserted between 10 and 1 and will occupy position 3. So let's see how. So here we will create a list node previous because we want to reach somehow to this node, which would be previous to our node after insertion. So we'll start from the head. So previous will point to head, and in order to reach to this node, we will keep the track using the count variable. So value of count will be 1 at the start, which signifies that we are already at this position. And then in order to traverse to a node previous to our position 3, we will provide a condition as count should be less than position minus 1. So position minus 1 will be 2. And here you can see that we have already taken up this place, so count is 1. So currently count is less than position minus 1, which is 1 is less than 2. So this condition comes out to be true. So we'll simply traverse previous to its next node by assigning previous.next to previous. So currently previous is pointing to this node, its next is pointing to this node. So we'll assign previous next value to previous. So it would look something like this, that now previous will point to its next node. Moving ahead, we'll increment value of count because we have traversed previous to its next node. Count becomes 2. Now here you can see 2 is not less than 3 minus 1, which is 2. And we also know that we have reached to position 2. And now we can simply use its next pointer to simply insert this node into the singly linked list at position 3. So this while loop condition comes out to be false. Now here what we'll do is, as we want to first break this link, so at the first step what we do is we simply create a list node current. We'll assign a value of previous.next to it. So as we want to break this link, so we can't directly break this link, because if we break this link, the nodes after that will be removed from the singly linked list because there would be no reference. So at the first step we are simply creating a temporary list node by name current, and we are assigning previous.next to it so that whatever the nodes are after that will be held by current. So previous next is this node. So now current will point to this node. So friends, now we need to perform two steps in order to insert node between 10 and 1. The first thing we need to do is, as node next is pointing to null, and we know that after its insertion it should point to this node, because that way it will be inserted in between of node 10 and 1. So at the first step what we are doing is, as current is pointing to this node, we will assign the value of current to nodes next. So here node next is pointing to null. So after this assignment there will be a linkage from node next to current. So it would look something like this. Moving ahead, and at the last step what we do is we simply break this link, and we can safely break this link because the rest of the list is being held by current. So how we can break this link is, previous is pointing to this node, its next is pointing to this node. So if we assign node's value, which is this value, to previous next, so it would look something like this. That now previous next is pointing to node by this assignment. And why we have performed this step is because we want to insert this node in between 10 and 1. So there was one linkage between 10 and 1. So we break that linkage. We assign previous next to node and node next to current. So here you can see that if we stretch this singly linked list ahead, so it would look something like this. That 7 will come in between 10 and 1. And here you can see that is the position 3 where we actually wanted to insert our node. This is position 1, 2 and this would be our 3. So it is nothing but inserting a node somewhere in the middle of the singly linked list. So friend, one last case remains is we want to insert node at the last. So that will also be inserted via position. So here you can see, let's say we are given with the singly linked list having only 2 nodes, 8 and 10. So this is position 1 and this is position 2. Now if you want to insert a node at the third position, so it would be nothing but inserting the node at the end of the singly linked list. And here we are assuming that position should be valid. So if we call insert 7, 3, 7 is our data and 3 is our position. At the first step, we'll create the list node having data as 7 and its next pointing to null. We check whether we want to insert at position 1 or not. So currently we want to insert at position 3. So this condition comes out to be false. Now in the else part, we perform the same steps which we saw in our previous slide. If we want to insert at position 3, we need to somehow traverse to position 2 so that we can use this link to insert this node. So we'll start previous from the head. And in order to keep the track of the position and where to insert the node, we'll create an integer variable count starting from value 1 because we have already taken up this value. In the while loop, we provide the condition as count should be less than position minus 1. Position minus 1 is 2 and as count value is 1, therefore the condition in while loop will come out to be true. In the first step, we'll simply traverse previous to its next node by assigning previous next value to previous. So it would look something like this. We'll increment count, so count becomes 2. And now here the condition in while loop comes out to be false because position minus 1 is 3 minus 1 which is 2 and 2 is not less than 2. So this will signify that previous is one step behind our position. So here you can see previous is pointing to position 2. And why we need a previous position is because as it is a singly linked list, we need to somehow use previous next pointer to simply accommodate our newly created node inside that. So at the first step, what we are doing is we are simply assigning previous next value to a temporary list node current. So previous next is pointing to null, so current will point to null. Now as we want to insert this node, what we saw in our previous steps, node next should point to current. So after this assignment, it would look something like this. That node next is pointing to null. So friends, here you can see as we are inserting this node at the end of the singly linked list, these steps are pretty much generic to accommodate both cases, inserting in between and inserting at the end. Now at the last step, we are simply assigning value of node to previous next. So previous next is pointing to null. So it means we want to reassign this value to this node because we want to insert this node at position 3. So it would look something like this. So now head is pointing to node 1. Node 1 is pointing to second node and second node is pointing to third node, which is our position 3. And this node is pointing to null because we have inserted this node at the end of the singly linked list. So it would look something like this. So here we discuss the cases where we want to insert the node at a particular position of the singly linked list. I hope the information provided in this video is useful to you. And in case if you find this useful, then please like this video. And in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.